Okay, guys, so we are done with differential equations for right now. We'll come back and review them as we get closer to the exam. But one of the things that I want to do is go back to u substitution. And this time I want to talk about how to do u substitution when we have definite integrals. If you remember, an indefinite integral looks like this, and a definite integral looks like this. Right? We have the limits of integration. So all of the u substitution problems that we did earlier look like this. I want to talk about what to do if we have limits on our definite integral sign. It's really the same process except for two little things. So we're still going to select a good choice for u. So you still choose u in the same way. You're still going to find du dx and get that differential dx to the other side. This is new. You're going to convert the limits of integration, in other words, your a and b, right? These two numbers right here. Right now, these are x values, right? Because we're plugging them into capital F of x. Well, not plus c, right? So they're x values. So we need to convert them from x values to u values. And I'll show you how to do that. It's real easy. We're still going to rewrite the integrand in terms of only u. We're going to integrate, same way. We are not going to substitute back in for u like we do with indefinite integrals. You know, with indefinite integrals, how we get like u squared plus c, and then we substitute back in like, I don't know, cosine of x squared plus c. We're not going to do that step when we have a definite integral, okay? And then the last thing is we're going to apply the fundamental theorem of calculus part 1 and actually plug in the b, plug in the a, and subtract them. Okay, so let's do the first problem. I have the integral from 1 to 3 of 2x minus 1 to the third power. In order to integrate this without u substitution, I'd have to multiply this out 3 times, and I don't really want to do that. So I'm going to let u equal 2x minus 1, which means that du is equal to 2 dx. So again, this whole thing is going to become u to the third, and I'm looking for just a dx. So I have to divide that 2 out. So I'm going to get 1/2 du is equal to dx. So now I know that this dx is going to get replaced with 1/2 du. Okay, here's the new stuff. I need to change these two limits of integration from x values to u values. So here's how I'm going to do that. When x is equal to 1, if I plug it into u, 2 times 1 is 2. 2 minus 1 is 1. So u is equal to 1. The other limit, 3, when x equals 3, 2 times 3 is 6. 6 minus 1 is 5. So now when I go to rewrite this, instead of writing from 1 to 3, I write from 1 to 5. And my integral, or my integrand, becomes u to the third times 1/2 du. And I can pull that 1/2 out and write it as the integral from 1 to 5 of u to the third du. And now I can integrate. So I get 1/2 times u to the fourth divided by 4. This time I'm not putting a plus c on. I'm doing the fundamental theorem of calculus. So if I do 1/2 times this 1/4, I get 1/8 u to the fourth from 1 to 5. And because these are u values instead of x values, I can plug them right in. So this becomes 1/8 times 5 to the fourth minus 1 to the fourth. Right? I plug 5 in, 5 to the fourth, plug 1 in, I get 1 to the fourth. So that's 1/8 times, what is that, 625 minus 1. So it's 624 divided by 8. Okay? So big difference is we have to change our limits to u values and we don't resubstitute back in. Okay? All right, this is definitely a typo. This was just supposed to be x squared plus 2 to the third. I'm not quite sure where that 6 came from. Okay, so this is the integral from -2 to -1 of x over x squared plus 2 to the third power dx. I am going to do a clever rewrite, and I'm going to bring that x squared plus 2 up and make it to the negative 3 times the x that was already up there, dx. I'm going to do u substitution because I can't multiply this out to the negative 3, so I'm going to let u equal x squared plus 3. du is equal to 2x dx. So here's my u to the negative 3. I need an x dx. So I'm going to divide that 1/2 out. So I now know this is u to the negative 3, and this is 1/2 du. I can actually go ahead and write that. I won't write my limits in. I have u to the negative 3 times 1/2 du. And now I've got to figure out my u limits. I'm running out of room down here, so I'm going to write them up here. So when x is equal to negative 2, and when x is equal to negative 1, because they're my two limits. So I have to figure out what u is. So I put negative 2 into u. Negative 2 squared is 4. 4 plus 3 is 7. When I put negative 1 in, negative 1 squared is 1 plus 3 is 4. So my limits, now be careful here. Negative 2 is at the bottom, right? And it goes with 7, so I have to put 7 at the bottom. Negative 1 was at the top, so I have to put 4 at the top. And that's a little crazy. We know what to do with that, right? Flip them to get them in the correct order, but that means I have to put the minus sign up in front. So I'm going to get negative integral from 4 to 7. Well, I'm going to pull that 1/2 out. Let's do this. Haha, like what I did there. So I'm going to flip it, make it negative. I'm going to pull the 1/2 out. I've got my limits in the correct order now. U to the negative 3 du. And now I'm going to integrate. Let's go with blue here. So negative 1/2 times the antiderivative of u to the negative 3 is u to the negative 2 over negative 2 from 4 to 7. All right, so let's clean this up. Negative 1/2, this is a negative 2, that's positive 1/4, and I'm going to drop the u down. Positive 1 over 4u squared. So that's 1 over 4 times 7 squared minus 1 over 4 times 4 squared. And I'm running out of room, so I'll let you guys figure out what that is. Free response, you don't have to simplify that. And since there's no multiple choice on this year's exam, you don't have to worry about it. All right? All right, I'm going to pause the video here. I want you guys to look at this problem. 0 to pi halves 4 sine of x over 2 dx. And I want you to see if you can set up that u substitution. Okay, so I just made this little note over here that x over 2, that's just a fancy way of writing 1/2 x. I prefer to write things that way instead of x over 2. I think it's easier to take the derivative. So I let u equal 1/2 x. du is 1/2 dx. I don't have a 1/2 there, so I multiplied the 2 over to the other side. So 2 du is equal to dx. When x is 0, u is 0, right? Because 1/2 times 0 is 0. When x is pi halves, well, 1/2 times pi halves is pi fourths. So my new limits are 0 to pi fourths. So here's what I have. I have integral from 0 to pi fourths. Here's my 4 sine of u times 2 du. Now I got two numbers here that are being multiplied. So I'm just going to pull the 4 and the 2 out and make it 8 integral from 0 to pi fourths of sine u du. And then I'm going to integrate. So what is the antiderivative of the sine of u? Well, if you said negative cosine, you would be correct. So negative 8 cosine of u from 0 to pi fourths. So we're going to plug in pi fourths, cosine of pi fourths minus cosine of 0, all multiplied by negative 8. That's root 2 over 2 minus 1. Distribute that negative 8 and you get negative 4 root 2 plus 8. Now some people might reverse that order because they don't like to start with a leading negative. I'm one of those people. But, so there's 3 examples. I'm going to do another video with 3 more examples, hopefully a little bit faster than this one, because I'll do like what I did with this one. But if you feel like you need to watch it, there's going to be some e's and natural logs you might want to watch. Okay?